in this video a real first test of the pancake coil oscillator, and I will the idea is, of course, in this video, when you have followed all the earlier videos, that there will be here a field effect transistor oscillator with a buffer, etc, etc. But of course it's very important as a first test to test that pancake coil. So I've connected it now to the more or less standard oscillator that I published many times, and I will give the link in the text box in the description. Field effect transistor oscillator, and here is a switch with which you can set in that oscillator different capacitors to the field effect transistor. One capacitor going from the gate to the source, and one from the source to ground, and that's set here in this circuit. And I have indicated here all the, say, positions of the switches of the first tests, etc, etc. And here again the value of capacitor 2 and capacitor 1. Capacitor 2 is the capacitor that's going from perhaps the gate to the source, and capacitor 1 is the other capacitor. So I want to refer to the real schematic in the earlier video, and there you can find everything. Here is the voltage that you can, say, set to make the oscillator work, and here two outputs, two output electrodes. One is to the counter and one to the scope. To the counter there is a smaller capacitor, output capacitor, in the picofarad range. Say it's 10 picofarad, and perhaps to the scope it is 30 picofarad, or reversed. Again, go to the real schematic that was published on my YouTube channel. The whole idea of this video is to test with this scope how the pancake coil works. My camera is flashing, so anyway, could be that I only can give a very small demo. Anyway, let's try. Here is a waveform that's generated now, and it is on 52 kilohertz. No problem with that. Let's switch to another position of the tuning capacitor here. You can see a slight change in the frequency, not very interesting, of course, on such a low frequency. Could be that 500 picofarad is not relevant. Anyway, let's set the oscillator to another position, and now we see a good sine wave, very proper sine wave on 115 kilohertz. Anyway, let's tune the capacitor, the tuning capacitor now, and see what happens. So 115 kilohertz, 133 kilohertz. Well, no problems with that. And I want to tell that we are on the same tab set with this switch and that switch. Let's switch this, the other switch, the base switch, to another position. Now we are on another frequency, 152 kilohertz. And now I want to set the test oscillator to another position where the capacitors in the gate part of the oscillator are changed. Again, want to refer to the earlier video anyway. And here we have a sine wave on approximately 284 kilohertz. Please note, this is only a very basic demonstration. Change some the parallel capacitance here. Let's see what happens. Of course, we go now with a higher parallel capacitance to a lower frequency, and here the oscillation stops. That has something to do with the say the cheap capacitor here. When you have a good quality capacitor, that will be no problem anyway. So again, and let's go to with the switch of the test oscillator to another capacitive input. Now nothing happens, and here we have another situation. 149 kilohertz. No problem with that. Change the tuning capacitor, and of course that has a serious effect on the frequency. The tuning capacitor goes between 70 picofarad and approximately 560 picofarad. That has a substantial effect on the frequency. Waveform is quite pure. Well, let's try to get to the highest frequencies. If possible, of course. Again, we are 158 kilohertz. That's not very high. Now we are on 653 kilohertz. Now it stops. So 653 kilohertz. That's okay. Tune the capacitor. Waveform deteriorates anyway. 765 kilohertz. No problem with that. Well, at the moment I cannot go higher. I'm absolutely sure that this oscillator can get the pancake coil, by the way, can get much higher. And perhaps I will do a new video about it, perhaps with a pancake coil that has less turns, less windings. Anyway, watch over. Looking over, that's what I mean. Looking over the circuit. Well, that was more or less all to tell. Thanks for watching. Of course, it's always interesting to get to the highest frequency that you can make with such an oscillator. Anyway,